Yeah, thanks, Peter. So I will try to be in time. So I'm happy to be here, and this is actually my third Reanalysis conference. I think the first one was in Maryland, and you will see how the work at EUMETSAT has actually evolved from that time until today. So we learned a lot in those almost 15 years now. And I have many co-authors here. So I wrote EUMETSAT Climate Team, so that's about an accumulation of about 20 people across the organization that contributed to this. And of course, we have two distinct co-workers at ECMWF, so that's Bill Bell and Paul Police, which are mostly receivers of what we produce and will use that in reanalysis or not. So they will tell us about the feedback, and then we can still see how we arrange that they are really being used in reanalysis. But that's quite, it's challenging, but also quite entertaining at times. So why we would support reanalysis? If you're working in an operational agency that's mostly supporting real-time applications like nowcasting and weather forecasting, so it's not so straightforward, so why shall you support reanalyses and you ask for a lot of money to reprocess data? So, but by now we see, in 2010 it was not really the case, but by now we see all these bullets on number one that you have heard yesterday, and this is amplifying the value of the satellite observation and the usage, and this is actually what is in the convention of EUMETSAT, so that's a very good argument to support that. But there's a second part to that, that by doing that, there's also a scientific and technical process behind it, and that drives consistent improvements across many scientific areas. And there are just a few lists. It's not only the observations, but it's nowadays also AI, ML, or data assimilation. So how do you use these observations in your data assimilation? But it has also technical components like, so what is the optimal computer setup to do reprocessing, which has also evolved a lot over time, and how you sort out data access for the ever-increasing volumes of satellite data. So for us, it was really advancing the quality of all our climate data records that we do in a big setup of satellite application facilities, and it's also a convenient push. It motivates improvement, and it partly funded our activities as well, so we could really do something which we couldn't do in the beginning, which I will show you. So I have stratified that in a couple of chapters. So the first one is about building up the science and operational support for reanalysis that takes really time and also resources in an operational agency. So if you see that plot, there's a time axis, so basically starting in 2009 and 10, going up to today. And in the beginning, we were supporting things like ERA 40 at ECMWF with about less than one person and had some responsibility when there was time. It was doing processing in a real-time ground segment in a satellite agency, which is, I can just tell you, it's a pain because you cannot change anything. So that's a long process to change anything. So it's basically not really what you want. But getting out of that wasn't very easy, and it took us a series of these colorful things like EU projects. There were two on reanalyses, which were very helpful in getting EUMETSAT into a position actually to learn how to reprocess, what to reprocess, and deliver that and get some feedback about this, to come to a position that we can do better mass reprocessing in a very traceable manner. We have also had Gaia Klim Fiducio that really taught us about uncertainty estimates in observations and how we do that in a metrological correct sense. So this was good, and it was accompanied by a growing infrastructure that we could use for reprocessing, so which was not foreseen in any satellite program. So you need to get the money to procure compute, which is much bigger than anything that you need for a real-time ground segment. So it's about 20 times bigger at least what you need so that you can do this also in decent time. Nowadays, and we had also the climate change service, so in there helping with this, we have a big system which has even power into elasticity, into a cloud, so we can do many parallel reprocessing streams of many instruments or things that we operate, but also historical data. So in 2018, so cutoff for ERA 5, so we had delivered a couple of data sets, so some from the headquarters on the right and some from our satellite application facilities, so 16 out of 54 satellite related. And some have stars here on the right and some have not. So they were partly reprocessed, but many were not. We just had no time, not enough power. So this has strongly improved. So then the question, so selecting what to do needs careful consideration. So we could just reprocess our sensor data for the satellites that we operate. So you have a YASI instrument, which is very good, and you can reprocess that and talk about improvements at a scale of less than 0.1 Kelvin. So is it worth it? Would it improve the reanalysis? So maybe not. So this was our original plan. But then we have learned, oh, it's better probably to look into a past reanalysis and figure out what are the issues and try to find instruments that would actually help in improving the reanalysis. So this is what we did. And we had a long discussion. You saw that plot yesterday, I think, in Bill's talk about the issues in the stratosphere in Era 5. And I will not go into any detail here, but reprocessed observations are part of the answer. And Bill has shown you some stuff yesterday. And I will not show you more here, but just show you the slide of observations that will be used in addition to what was used in Era 5. So don't give the colors in the bars. There's all time bars of different satellites and long series down to 1970. But we concentrated a lot on historical data which provide, for example, information in the stratosphere. So this is this SSH sounder that has some CO2 channels in the stratosphere. There's SSMT in a microwave sounding. There's also channels in the stratosphere in addition to the MSU instrument. And we work on some improvements, like on SSMIS, that had also channels which you haven't even touched yet. We're just starting looking at those, so nobody has ever used them apparently, so that's quite exciting to look at those. And then we redo long series, as Paul has shown, on HERS, MSU, AMSU-A, to make them really consistent and traceable over time. And this is one example I will show you on the HERS. So what you see here is a HERS record on top. From 1980, and this is a CO2 channel, so you see this slight cooling, and that's exactly what Bill described yesterday. So that's the CO2 in the atmosphere that is pushing up the weighting function, and that effect is stronger than the warming. So that's why you see a negative trend. Many people ask about that when you present that in a climate conference. Oh, why is the temperature decreasing? Yeah. And we have also consolidated archives here from NOAA and ECMWF, so they were different. So we we found data, so now this seems to be complete. And when you simulate that with Era 5, then it looks a pretty good status. And this is data which are not intercalibrated. So this is just out of the box. We just improved the calibration of each single instrument consistently by using the last calibration algorithm. For the first 20 years or so, the calibration was not considering the self-emission of the instrument, which is quite important for a sensor that has an orbit which has different times in sunlight and shadow. So it's heating up, and if you don't consider that in a calibration, you get weird responses. So this has just been corrected. It was not a big effort. So we did this not only for reanalyses, but of course also to recalibrate geostationary radiances, which are in order less accurate mostly than the HERS. So we're looking for a reference. We had YASI, AS. Well, what do we do prior to AS? There's only HERS that is comparable. So, and you see for nowadays 2005, you see a different color. So the pink AAPP HERS is our reprocess, always the same as the operational, compares very well to AS. There was a research project that fell a little bit off, so in 2005. But if you do that for old instruments in 1984, then you see distinct differences in the calibration with the reprocess, and that's just reducing the scatter on the right for the collocated data between HERS and the Meteosats. So this is strongly improving and harmonizing the Meteosat record to the same level of calibration quality. And you show this left plot in Hans' talk yesterday. This is so basically the experiment that was run with this reprocessed HERS data in the Era 6 setting, and it has throughout positive effects on temperature and also on the winds, even up in the stratosphere. So it's exactly what we all hope for to see. And it also fills some gaps on the right side in the record or in certain months and years. Another one is so never surrender. So historic data, so not even typing in situ data, but this is the example of deriving atmospheric motion vectors from an instrument called THERA, so the temperature humidity infrared radiometer. So that was on Nimbus 4, 5, and 6. So you see data coverage in 1970 quite good, then was a kind of a lot of outage, and then later Nimbus 7 is better. It has one window channel in infrared with 8-kilometer resolution, so you can do decent AMVs maybe. This was our first attempt. So wind speed, vector height, difference to Era 5 looks horrible. No? So the profile, which is the blue profile compared to the forecast profile, so it's not working at all. No? So why is that? We just use an algorithm that we use for AVHR, so something is very different. So back to the quality analysis of the data. So we went in there and really found tons of errors in the already reprocessed FDR of those data and analyzed that and looked for consecutive orbits, changed our algorithm. And in the end, we got some credible wins out. So this is the wins plotted on the geopotential of era 5. So that looks pretty good. It's not the same. It's not completely parallel. That's good. So it contains some signal. And the winds are mostly upper atmosphere, and the blue line is basically the bias, and the spread is the RMS. It's not much worse than the AVHR polar wind. So it's quite probably, I look forward to the experiment, what impact that might have in 1970. So I need to speed up. So metrology, I talked about this. So how to use these uncertainty estimates in the satellite data and reanalysis. So they are not considered really in the data assimilation because that's pretty complex, I guess, in a 4D VAR to do that. But we plan ways around that by probably so that ECMWF could withdraw instruments like the NOAA NPP CRIS from the assimilation, and then we can use that to compare simulations with the characterized data in a systematic manner, and that would give us probably some light on systematic uncertainty. So the last chapter I need to skip. It's about Mediasat data. There's a poster outside, but the message is they are underutilized. If you go to higher resolution, and you may well do, you need to use them because this is the only measurement that tells you a lot about diurnal cycle in the atmosphere and the surface. So that's important to be considered. And the good news is here that we prepare actually a lot of data together with NOAA and JMA in a joint project that is also now joined by India, by IMD, by delivering data in that missing white box over the Indian Ocean, so we get much more completeness. So we get 10 years more geostationary observations that we will analyze and put together into what we call the GeoRing record. So I'll leave that up to read. The QR code you can scan. This brings you directly to a catalog of the data in our EUMETSAT data store, which is fairly simple and also same design almost as the climate data store because it's done by the same person. Thank you very much.